The gray dawn of June 10, 1944, was not a reprieve for Oberleutnant Karl Richter. 5 days after the initial fury of Operation Overlord, the seasoned German artillery observer found himself once more scanning the churning waters and the pockmarked sands of Omaha Beach from his camouflaged observation post. His binoculars, perpetually gridded with sand and sea spray, revealed not the aftermath of a climactic battle, but an ongoing, relentless process of materialization. Wave after wave, the flat-bottomed landing craft, LSTs and LCTs, continued to disgorge their immense cargoes. Sherman tanks, their tracks grinding against the shingle, rumbled ashore. Jeeps, trucks, and the ubiquitous amphibious Dukws, laden with ammunition, fuel, and rations, crawled from the ramps and navigated the beach obstacles towards the emergent road networks. Beyond them, a seemingly endless flotilla of larger transports dotted the horizon, waiting their turn to unload. Richter had witnessed the initial terrifying storm of the invasion, but what he now observed was far more insidious, far more crushing to the German spirit. This was not merely an army. This was an industrial process given kinetic form. The Allied logistical throughput, a continuous and accelerating conveyor belt stretching across the English Channel, was an existential horror. Each departing vessel, having delivered its payload, immediately turned to make the return journey, only to be replaced by another and another. Richter understood, with a chilling, irrefutable clarity, that the fight was not against individual battalions or even entire divisions. They were contending with an entirely new kind of adversary, an industrial military leviathan of unprecedented scale, a boundless stream of material that could not be starved, could not be halted. This wasn't a tactical problem. It was an insurmountable mathematical equation. Germany, he realized with a dawning despair, was not fighting soldiers, it was fighting factories. The German officer's harrowing revelation that his forces were not merely battling soldiers but entire industrial ecosystems encapsulates a profound truth about the D-Day invasion. While the valor of the Allied infantry storming the beaches is rightly etched into history, their success hinged upon a far less visible yet infinitely more powerful force. This force was the colossal logistical machine of the Allied powers. D-Day, at its core, was not a tactical masterpiece won solely on the sands of Normandy, but a logistical triumph meticulously engineered in the strategic planning rooms, the bustling shipyards, and the relentless production lines stretching from the American Midwest to the British Isles. For every bullet fired, every tank advancing, every medic attending to the wounded, there was an unseen chain of supply, a carefully orchestrated symphony of transportation and resource management that defined the very parameters of the battle. The true battlefield, therefore, extended far beyond the German coastal defenses. It was fought in the factories churning out Sherman tanks at an unimaginable rate, in the meticulously designed blueprints for artificial harbors, and in the intricate schedules that dictated the movement of 7,000 vessels across the Channel. This overwhelming advantage in material and sustainment was not incidental. It was the deliberate, calculated outcome of an industrial and organizational mobilization unprecedented in human history. While the world remembers the gallantry of the infantry assaulting the beaches, the true architects of D-Day's success operated in the shadows. Their battle fought on maps and ledgers. This monumental undertaking, christened Operation Overlord, demanded a logistical calculus unlike any seen before in military history. The challenge was not merely to land an army, but to project the full industrial might of the Allied nations onto a hostile shore, and sustain a continental campaign from a beachhead. The scale of this logistical planning was truly unprecedented. Imagine moving an entire field army, hundreds of thousands of men, tens of thousands of vehicles, and millions of tons of supplies across 100 miles of treacherous water under constant threat from enemy U-boats and aircraft, then establishing a fully functional supply chain on an undeveloped coastline. Every single item, from a rifle cartridge to a surgical needle, from a tank engine to a pint of blood plasma, had to be accounted for, sourced, packed, transported, and delivered precisely when and where it was needed. Maintaining absolute secrecy throughout this gargantuan planning phase was paramount. While the deception operations of Fortitude captivated German intelligence, the logistical planners worked in compartmentalized units, each knowing only its piece of the immense puzzle. This intricate web of planning committees and working groups, spanning both the British and American high commands, wrestled with staggering operational parameters. They meticulously calculated projected consumption rates for ammunition, fuel, and rations, not just for the initial assault, but for weeks and months beyond. Statistical models were developed to forecast everything from the number of replacement tires needed for trucks to the quantity of barbed wire required for defensive perimeters. Key figures like General Brehon B. Somervell, head of the U.S. Army Services of Supply, and his British counterparts, oversaw an army of statisticians, engineers, and transportation experts. Their task extended far beyond mere inventory. It involved designing bespoke landing craft, developing revolutionary port solutions like the Mulberry Harbors, which we will explore in detail, and devising innovative fuel delivery systems such as Operation Pluto. They had to foresee every contingency, from adverse weather impeding convoys to enemy action disrupting supply dumps. This was a war fought with spreadsheets and shipping manifests as much as with rifles and artillery, a testament to the power of meticulous planning in the face of overwhelming complexity. The sheer scale of the logistical challenge, born from those meticulous spreadsheets and shipping manifests, culminated in an assembly that defied imagination, the invasion armada itself. This was not merely a collection of troop ships. It was the largest naval fleet ever assembled, a floating city comprising nearly 7,000 vessels. To grasp the true magnitude, consider its composition. At its core were approximately 1,200 warships, battleships, cruisers, and destroyers, poised to unleash unparalleled naval gunfire support. But the true workhorses, the very sinews of the amphibious assault, were the 4,126 landing craft of various designs. From the capacious landing ship tank, or LST, capable of disgorging dozens of vehicles directly onto the beach, to the smaller landing craft infantry and landing craft vehicle personnel, each was purpose-built for the brutal exigencies of a hostile landing. Alongside these were some 800 transport ships, brimming with troops, tanks, artillery, and the millions of tons of supplies required to sustain a continental campaign. Hospital ships, their red crosses emblazoned against the gray skies, stood ready for the inevitable casualties. And crucially, a vast supporting cast of auxiliary vessels. Hundreds of minesweepers to clear the treacherous paths, tugboats to manage the artificial harbors, repair ships, salvage vessels, and even barrage balloon tenders, all playing vital, often unsung roles in the seamless operation. Assembling this gargantuan fleet was a logistical ballet of unprecedented complexity. Over a dozen major ports and countless smaller inlets across southern England became staging areas, each humming with activity under absolute secrecy. Every single vessel was meticulously loaded according to its precise manifest, down to the last rifle cartridge and field dressing. Troops boarded their designated transports, vehicles were marshaled into their allocated landing craft, all according to a rigid timetable and a pre-calculated sequence of deployment. The coordination extended to rendezvous points in the English Channel, where disparate convoys from various ports would converge, forming the vast, silent procession that would cross the 100 miles to the Normandy coast under the cover of darkness. This was a logistical pipeline made manifest in steel, ready to deliver the full industrial might of the Allies directly to the enemy's doorstep. The preparatory phase for Operation Overlord was a logistical imperative on a scale previously unimaginable. England, the launchpad for the invasion, was systematically transformed into one vast armed camp, a colossal staging area brimming with the materiel of war. Every available field, every warehouse, and every hidden stretch of woodland became a temporary home for the colossal stores of equipment and supplies. This accumulation was not merely extensive, it was staggering, a testament to the industrial might of the Allied nations and the meticulous planning of Quartermaster Corps officers. Consider the sheer volume. By late May 1944, nearly 3 million tons of supplies had been amassed across southern England. This included an estimated 1.5 million individual items, each meticulously inventoried and positioned for rapid deployment.
Vast vehicle parks, some stretching for miles, contained over 200,000 jeeps, trucks, and half-tracks, ready to ferry men and equipment from the beaches inland. Ammunition dumps, carefully dispersed to mitigate the risk of aerial attack, held millions of rounds for small arms and tens of thousands of tons of artillery shells, ranging from 75mm to the massive naval ordnance that would soften German defenses. The fuel requirement alone was monumental. Millions of gallons of gasoline, diesel, and aviation fuel were stored in intricate networks of underground tanks and surface depots, awaiting the construction of the underwater Pluto pipeline and the arrival of fuel tankers. Beyond the heavy equipment, the mundane but critical supplies were equally abundant. Enough rations to feed hundreds of thousands of men for weeks, mountains of medical supplies, engineering equipment for fortifications, and bridging materials to span rivers and craters. This methodical, almost industrial-scale stockpiling was the physical manifestation of Allied resolve, a visible and tangible promise that once the invasion began, it would be fed relentlessly, ensuring that the initial breach was not merely a raid, but the unstoppable spearhead of liberation. While the Allied invasion fleet represented an unprecedented concentration of naval power, its ultimate success hinged not merely on reaching the Normandy beaches, but on sustaining the landing force. The critical choke point, a factor that had bedeviled amphibious operations throughout history, was the necessity of a deep-water port. German doctrine understood this, fortifying every major port along the Atlantic Wall into an impregnable fortress. Yet, Allied strategists conceived a solution so audacious, so unprecedented in its scale, that it would effectively nullify this formidable defensive advantage. This revolutionary concept, codenamed Mulberry, envisioned the construction of two massive artificial harbors, prefabricated in sections across Britain, then towed across the tempestuous English Channel and assembled off the Normandy coast. The genesis of the idea is often attributed to Winston Churchill, who, as early as 1942, pondered the feasibility of floating piers. From this initial spark, engineers and naval architects developed a detailed blueprint for what would become one of the greatest engineering feats of the war.
The Mulberry Harbors were intricate systems comprising several key components. Gigantic concrete caissons, known as Phoenix units, some as large as 5-story buildings and weighing up to 6,000 tons, formed the outer breakwaters, providing essential protection from the channel's relentless currents and tides. Inside this man-made lagoon, floating roadways, dubbed whales, were supported by pontoon units called beetles, creating a flexible pier system capable of rising and falling with the tide. These roadways then connected to pierheads, purpose-built floating docks where Liberty ships and other cargo vessels could tie up and offload their vital supplies directly onto trucks. The scale of this undertaking was immense. Thousands of workers toiled round the clock in British shipyards and construction sites, fabricating over 600,000 tons of concrete and steel. Following D-Day, these colossal structures were meticulously towed across the channel by a flotilla of tugboats, a perilous journey in itself, and then precisely positioned and sunk or anchored into place. Within days, two fully functional ports, Mulberry A for the American sector off Omaha Beach and Mulberry B for the British and Canadian forces off Gold Beach, began receiving cargo. Mulberry A, unfortunately, was severely damaged by a ferocious storm just weeks after deployment, proving the channel's unpredictable nature. However, Mulberry B, quickly dubbed Port Winston, continued to operate for 10 months, handling over 2.5 million men, 500,000 vehicles, and 4 million tons of supplies. This ingenious solution effectively bypassed the need to capture heavily defended deep-water ports like Cherbourg, which the Germans had systematically destroyed anyway. It transformed an insurmountable logistical bottleneck into a continuous, high-volume pipeline, demonstrating that Allied industrial capacity and engineering prowess could literally reshape the coastline to meet the demands of an unprecedented invasion. The Mulberry Harbors were not just feats of engineering, they were the physical embodiment of the Allied resolve to sustain the fight, no matter the obstacle. Even as Allied forces consolidated their initial gains and pushed inland, the monumental challenge of sustaining a rapidly advancing mechanized army loomed large. Every tank, every truck, every aircraft demanded a constant, prodigious supply of fuel,
petroleum, oil, and lubricants, or POL. Traditional methods of bulk transport via tanker ships and subsequent transshipment by jerrycan or truck were too slow, too vulnerable, and utterly inadequate for the scale of the impending strategic thrusts. The solution was a feat of engineering audacity, Operation Pluto, an acronym for Pipeline Under the Ocean. Conceived by British engineers, this groundbreaking project sought to eliminate the logistical bottleneck of fuel supply by laying direct undersea pipelines from England to the beaches of Normandy. The technical challenges were immense. A pipeline needed to be flexible enough to be spooled and laid by ship, yet robust enough to withstand immense underwater pressures and the corrosive saltwater environment. Two primary designs emerged: the Haas cable, adapted from a submarine telegraph cable with a lead core, and the Hamels pipe, a flexible steel pipe that could be coiled onto giant floating drums called conundrums.
Installation was a meticulous, high-stakes endeavor. Specialized ships, often disguised as merchant vessels to avoid German aerial reconnaissance, systematically laid these pipes across the English Channel. The first lines, operational by August 1944, began delivering vital petrol directly to a receiving station on the Cotentin Peninsula. By the time Paris was liberated, Pluto was delivering hundreds of thousands of gallons of fuel daily, bypassing the congested ports and the hazards of surface transport. This continuous, virtually invulnerable flow of POL was a strategic imperative, a literal lifeline that fueled the Allied war machine. It enabled the rapid exploitation of breakthroughs, sustained the relentless air superiority that crippled German counterattacks, and ultimately ensured that the Allied armored divisions could maintain their momentum, driving deep into enemy territory. Pluto was not just a pipeline, it was an invisible artery of industrial power, pumping the lifeblood of modern warfare directly to the front. While Pluto promised an invisible strategic artery for fuel, the immediate visceral challenge of D-Day logistics lay in the perilous journey from ship to shore. This was where the ingenious amphibious vehicle, the Dukw, affectionately known as the Dukw, proved its indispensable worth. A 6-wheel drive, 2.5-ton truck, the Dukw was specifically designed to operate equally well in water and on land. It could load directly from Liberty ships and landing ship tanks, LSTs, anchored offshore, navigate the treacherous surf and tidal currents, and then drive straight up the beach and often several miles inland to designated supply points. This capability bypassed the critical logistical bottleneck of needing established port facilities, a luxury unavailable in the initial hours and days of the Normandy landings. The relentless parade of Dukws, each laden with ammunition, rations, medical supplies, or fresh troops, formed a continuous conveyor belt, transforming the chaotic beaches into a viable, albeit dangerous, staging ground. But managing this torrent of materiel and manpower under constant enemy fire required an extraordinary level of organization. This fell to the naval beach battalions, whose officers were famously known as beachmasters. These courageous individuals were tasked with the Herculean effort of directing traffic, clearing disabled vehicles, marking safe lanes through minefields, and coordinating the evacuation of casualties, all while establishing the initial supply dumps directly behind the landing zones. The beachmasters were the linchpins of the beachhead operations, transforming potential gridlock into a functional, if rudimentary, logistical hub. Their objective was simple yet profound: ensure that the fighting troops pushing inland were continuously resupplied, preventing any pause in the offensive that could allow German forces to consolidate. The precision and sheer volume achieved by these combined efforts, the amphibious capability of the Dukws meshing with the disciplined organization of the beachmasters, underscored the Allies' profound understanding that victory in modern warfare was as much about the efficiency of the supply chain as it was about battlefield prowess. With the beachheads finally consolidated and the initial wave of material firmly established ashore, the monumental logistical challenge for the Allies shifted from sea to land delivery to the rapid establishment of inland supply routes. The advance into France was not merely a matter of tactical maneuver, it was fundamentally dependent on an unfailing artery of supply, a relentless flow of ammunition, fuel, food, and equipment following hard on the heels of the fighting formations. The immediate terrain presented formidable obstacles. The intricate network of French roads, vital arteries for any advance, lay scarred by cratering, collapsed bridges, and deliberate demolitions by retreating Wehrmacht forces. Allied engineers, primarily from the U.S. Army Corps of Engineers and the British Royal Engineers, faced the Herculean task of repairing main thoroughfares, constructing temporary bridges, and clearing vast quantities of rubble and unexploded ordnance. Simultaneously, forward supply depots had to be rapidly established, often just behind the advancing front lines, demanding meticulous planning for site security, rapid construction of storage facilities, and efficient distribution points. The scale of this requirement soon outstripped conventional transport methods. The rapid breakout from the Normandy bocage and the subsequent pursuit across France by divisions like Patton's Third Army created an unprecedented demand for fuel and ammunition, pushing supply lines to their absolute limit. It was this urgent need that gave birth to one of the most celebrated logistical feats of the war, the Red Ball Express. In operation from August to November 1944, the Red Ball Express was a dedicated, high-speed, one-way trucking system designed to shuttle supplies from the Normandy ports and beaches directly to the front. Utilizing two primary routes, one for outbound laden trucks, another for empty return vehicles, it circumvented congestion and ensured continuous flow. At its peak, over 5,900 trucks, many driven by African American soldiers of the Transportation Corps, operated 24 hours a day, 7 days a week, delivering an average of 12,500 tons of supplies daily. This extraordinary logistical corridor, marked by distinctive red ball signs, became the lifeblood of the Allied advance, a visceral demonstration that in modern warfare, the speed of supply could be as decisive as the speed of tactical deployment. While the Red Ball Express furiously pushed material to the front lines, sustaining the Allied advance with an unprecedented flow of supplies, an equally vital yet often overlooked logistical pipeline operated in reverse, the meticulous and massive system for evacuating casualties. This intricate chain of care was a testament not only to medical ingenuity, but to the sheer industrial and organizational capacity of the Allied forces, designed to minimize loss of life and, crucially, uphold troop morale under the brutal conditions of battle. From the moment a soldier fell, the system sprang into action. Frontline medics, often under direct fire, administered immediate first aid, stabilizing wounds with tourniquets, bandages, and morphine syrettes. Casualties were then rapidly moved by stretcher bearers, jeeps, or specialized armored ambulances to regimental aid stations, and subsequently to more robust clearing companies, which served as forward surgical centers. Here, medical personnel performed initial triage, emergency surgery, and prepared the wounded for further transport. The emphasis was always on speed and efficiency, acknowledging that the golden hour for critical trauma care was paramount. From these field facilities, the wounded were then routed through a network of casualty collecting points and evacuation hospitals, situated further back from the immediate combat zone. These larger installations provided more comprehensive surgical procedures and intensive post-operative care. For those requiring extensive treatment or rehabilitation, the journey continued. They were transported by dedicated ambulance trains or convoys to major port facilities in Normandy, such as the rehabilitated Cherbourg or the artificial Mulberry Harbors themselves, which, beyond their cargo capacity, also facilitated reverse logistics. Waiting at these ports were the hospital ships, floating bastions of medical expertise, fully equipped with operating theaters, wards, and highly trained staff. These vessels, clearly marked with red crosses and operating under international conventions, ferried thousands of wounded across the treacherous English Channel to the safety of major hospitals in Britain. The scale of this operation was immense. Hundreds of thousands of Allied personnel were evacuated and treated throughout the campaign. This systematic approach, leveraging advanced medical techniques like blood transfusions and the nascent use of penicillin, dramatically reduced mortality rates from wounds compared to earlier conflicts. The knowledge that a sophisticated, dedicated system existed to retrieve and care for the wounded was a profound psychological boost for the fighting troops, affirming their value and bolstering their willingness to confront danger.
This seamless integration of medical support into the broader logistical framework underscored a fundamental truth of modern warfare. Victory is not only won by the relentless push of material forward, but also by the unwavering commitment to the human element, ensuring that the cost in lives, though inevitable, was never needlessly compounded by a failure of care. While the Allied juggernaut relentlessly poured men and material onto the Norman beaches and into the continental interior, the German logistical apparatus was a study in stark, agonizing contrast. Far from the modern mechanized columns of the Western Allies, the Wehrmacht, particularly in its rear echelons and infantry divisions, remained heavily reliant on an antiquated transport system. Hundreds of thousands of horses, enduring beasts of burden, pulled supply wagons and artillery pieces across the battlefields of Europe, a stark visual testament to Germany's material limitations. This reliance on animal transport severely restricted their operational tempo, making rapid redeployments or sustained offensives an increasingly untenable proposition, especially under the ever-present threat of air attack. The chronic fuel shortage was perhaps the most debilitating factor. Allied strategic bombing campaigns had systematically targeted Germany's synthetic fuel plants and oil reserves, throttling the very lifeblood of their armored and mechanized forces. Tanks and trucks, even when available, frequently sat idle for lack of gasoline, a critical operational paralysis that negated their tactical advantages. Commanders often faced agonizing choices: move a panzer division to a critical sector or conserve fuel for a potential future counterattack that might never materialize. This scarcity meant that every gallon was precious, every movement meticulously calculated, and often too little, too late. Compounding these internal deficiencies was the overwhelming Allied air superiority. The skies over Normandy were firmly under Allied dominion, transforming German logistical movements into suicidal endeavors. Any significant daytime road or rail movement was immediately identified and savaged by fighter bombers, turning supply convoys into flaming wrecks and rail lines into twisted metal. Bridges were systematically destroyed, marshalling yards pulverized, and communication networks severed. This relentless aerial interdiction meant that reinforcements, ammunition, and vital supplies trickled to the front lines at a glacial pace, if they arrived at all. German armored divisions, designed for rapid, decisive thrusts, found themselves immobilized, starved of ordnance and fuel, unable to mass effectively for counterattacks or sustain defensive positions against the Allied onslaught. The German inability to move men and material effectively was not merely an inconvenience, it was a fundamental strategic deficiency that systematically eroded their capacity to wage modern warfare, leading directly to the piecemeal destruction of their forces and the ultimate unraveling of their defense in the West.
Die Profound-Realisation bei German Commanders auf deren fundamentale logistische Inferiorität, als deren Kapazität zu wegen moderner Warfare systematisch erodierte, stand in stark Kontrast zu der alliierten logistischen Meisterie, demonstriert deren und nach D-Day. Diese Meisterie war nicht nur eine taktische Expedient für eine kolossale Operation, es konstituierte einen fundamentalen Paradigmen-Shift, das vor Ende alterte den Blueprint von modernen Militärdoktrin. Prior zum D-Day, Logistik war oft relegiert zu einem Supportenrolle, eine essentielle, aber sekundäre Konsideration zu Grandstrategie und Battlefield-Taktik. Die Normandie-Invasion irrevokabel erhöhte es zu eine coequebe Pillar von Warfare. Das unerhörte Challenge von Projektieren und Sustainen eine ganze Army-Gruppe auf einem contesteten Seeline forderte alliierte Planer zu integrieren logistische Konsiderationen von den naziesten Stadien von strategischer Konzeption, Rande wie treten sie als eine Afterthought. Dies holistische Approach encompassen alles von spezialisierten amphibischen Assaultcraft und präfabrizierten Hafen zu Vast Ground Transportation Netzwerken bekam der endurende Model für future-expeditionäre Operationen. Die Ingeniosität displayed mit den Mulberry Harbors und Operation Pluto, die Unterwasser-Fuel-Pipelines, demonstrierte, dass kritische Infrastruktur könnte ingeniert und deployed werden, um geografische und taktische Konstränden zu überwinden. Dieses Prinzip von Kreieren bespoke logistische Solutionen, anpassbar an spezifische operationale Umgebungen, kontinuiert zu informieren kontemporäre Militäringenieure und die Entwicklung von modularer deployabler Supportsystemen für Forces operieren in austerer oder unentwickelten Theatern. Similarly, die relentlose Effizienz von spezialisierten Vehikeln wie der Dukw und die vaste Kapazität von Landing Ships Tanks, LSTs, unterstrichen die kritische Not für robuste, multimodale Transportkapazitäten, capable von Brücken den cruislichen Last Tactical Mile von See zu Shore und dann Deep Inland. Der Red Ball Express, eine dedizierte Highway auf Supply Trucks, exemplifizierte die Notwendigkeit für High-Speed, sichere und resiliente Ground-Distributionsnetzwerke, um rasch Materiell von den Beaches und Ports direkt zu den advancen Frontlinien zu führen. Moderne Militärlogistik, weil nun leveraging sophisticated Data Analytics, automatisierte Inventurmanagement und Global Tracking Systeme, still operates on this foundational principle, maintaining einen unanbrochenen high-velocity flow of supplies to sustain operational tempo und momentum.
From the massive mobilization plans of the Cold War to the intricate supply chains supporting expeditionary forces in the Gulf Wars and Afghanistan, the lessons of D-Day resonate. The ability of a nation to project and sustain military power globally is at its core a logistical triumph or failure. Today, with the added complexities of cyber warfare and hybrid threats, the resilience and security of military supply chains have never been more critical. The logistical innovations forged in the crucible of D-Day laid the enduring groundwork, transforming the unseen machine of supply and support into the undeniable engine of victory, whose principles continue to shape every major military undertaking.